Good afternoon, madam.
Good afternoon.
I can see Professor Ramakrishna there. Can we start?
Yes, madam. We can start, madam. Today, this is the monthly talk of the AIMS Research Forum. We have Dr. Ramakrishna as the invited speaker from that side. I request our director, madam, to give the welcome address to our invited speaker.
Good afternoon, Professor Ramakrishna. Good afternoon, sir. Can you hear me? Can you hear me?
Sorry, yes, I think I had it on mute. Yes.
Yes. Good afternoon, sir, and thank you very much for joining AIMS Bhubaneswar Research Forum. This is a monthly research forum where we have one lead talk given by a speaker of eminence, and then we try to discuss some of our own research work, which is presented by residents, faculty, and we just get to know what is going on. So we've started this, and I think this is the 6th or 7th in its series. So thank you very much, sir, for joining us. I will briefly introduce you. I have the privilege to introduce Professor B.S. Ramakrishna, who is presently the Director, Institute of Gastroenterology, SRM Institutes for Medical Science, Vadapalani in Chennai. He is also an adjunct professor of medicine at the Yale University School of Medicine, New Haven, USA. Professor Ramakrishna did his MBBS, his MD in general medicine, his DM in medical gastroenterology, all from CMC Vellore. And he has been associated with CMC Vellore from 1979 to 2012. That is nearly more than 3 decades he has been associated with CMC Vellore Hospital. He has a great many honors. He's a fellow of the National Academy of Medical Sciences, Indian Academy of Sciences, Indian National Science Academy, a fellow of the American Gastroenterological Association, and he's the past president of the Indian Society of Gastroenterology. He has more than 170 journal articles. He has written more than 20 book chapters. He has a patent. He has 6 gene bank submissions. He is, in effect, a person who we could aptly, take as an example of a physician scientist. And that is why, since we are in our own institute looking to encourage physician scientists, especially with our recent discussions with the Indian Institute of Science, we want to encourage this peculiar breed, or I would say an endangered species of physician scientists. So Professor Ramakrishna's biodata is something like one which all of us would aspire to have. And I just read it and I was so blown away with the kind of biodata he has. But unfortunately, I won't go into it in detail. Professor Ramakrishna, my sincere, I welcome you to this program, and thank you for agreeing. For physician scientists, the need to create, foster, and motivate. Welcome, sir. I request you to kindly share your presentation.
Thank you very much. So at the outset, may I thank you, Dr. Geeta Jilli, the director, and the Dean Research for inviting me to speak at this forum. It's a great honor. So as Dr. Geeta Jilli introduced me, so basically I am a physician. I am a gastroenterologist. I continue to see patients 6 days a week, and I treat patients, and I do complex endoscopic procedures on the bile ducts and pancreas. But besides this, I've also had a lifelong interest in research. And when in CMC, I had a research lab, which was fairly big, reasonably productive. And now that I'm here in SIMS in the private sector, I still have a research lab. We are here researching the human microbiome. I'm part of a collaborative initiative spanning India, which is called the Indian Human Microbiome Initiative. And my other interest is how the microbiome links to intestinal and extra-intestinal inflammation. So I have my clinical interest, but I also have my research interest. And what I'm going to talk to you about is the concept of physician-scientists and how, as Gitanjali said, to foster this kind of endangered species. So if we look at physicians versus physician-scientists, now shown on this slide are two of the greatest physicians of all time. On the left, you have a bust of Hippocrates, who lived 2,500 years ago. He created the systematic documentation and study of medicine in his times, of course. Now, Hippocrates was also responsible for telling physicians how to practice ethically. And the Hippocratic oath, which he generated, is something to which, as medical students, we swore when we became graduates. To this day, people take the Hippocratic oath or some version of it whenever they graduate. On the right here is William Osler. So Hippocrates was called the father of medicine, rightly so. On the right is William Osler, who's a Canadian physician. And he was considered one of the greatest diagnosticians who's ever lived. Of course, in those days, they didn't have the benefit of ultrasounds and CT scans and MRIs. And so he had to make do with his eyes, ears, and with his fingers. And what William Osler did was, until then, learning medicine was a question of apprenticeship. It was very informal. He introduced the residency system, which we follow to this day, which is how postgraduates are taught. There's a very formal training program that they go through. William Osler was also one of the founders of the Johns Hopkins Hospital, and he's called the father of modern medicine. So these were great physicians. On this slide here, I've shown 4 people who were physician scientists, and they were, of course, from an earlier era. There's William Harvey, who discovered the blood circulation. He was the first to show that the heart pumped blood and it returned to the heart, and he calculated the number of times the blood would go through. Otherwise, people didn't really know about this. Then there's Edward Jenner, who originated vaccination. He experimented on many children, including his own son, injected cowpox and showed that it prevented smallpox. Then we have William Withering, who was an English physician who also studied botany. And so he used the foxglove to cure heart failure. And he isolated the active principle of foxglove, which is digitalis. This is something that chemists to this day still do. We try to isolate the active principle through various chemical or physical means, and then try to see if we can synthesize that. And then on the extreme right, we have Frederick Banting, a Canadian physician who incidentally trained as an orthopedic surgeon, then decided to go into research. He isolated insulin from the pancreas and discovered insulin, and he got the Nobel Prize for that. And he found the cure for diabetes. We have more modern people that we can talk about. And here is an example of a surgeon who was outstanding, Thomas Starzl, who was the pioneer of organ transplantation. So Starzl, in addition to doing these complex surgeries where he saved so many lives with transplants, he also meticulously documented everything that he did. He kept changing his protocols till he got them right. He kept refining the immune treatments till he got them for his day right. And so he was a great scientist too. So he is another an example of a physician scientist. And then we have Ralph Steinman. So I don't know how many of you have heard of him, but he was an MD from Harvard, practiced in Canada. He researched dendritic cells and showed that they are sentinels of the immune system. He experimented with dendritic cell vaccines. Unfortunately, Dr. Steinman in 2007 developed pancreatic cancer. He treated himself with dendritic cell vaccines and managed to live for 4.5 years. He died in 2011. At the time that he died, the Nobel Committee was sitting to decide on who would win the Nobel Prize that year in medicine. And 2 days later, they announced the Nobel Prize and Ralph Steinman got it. They did not know that he had died 2 days prior to that. Then we have Barry Marshall and Robin Warren. And the reason I put them up here is because they challenged dogma. So Barry Marshall was a young gastroenterologist from Australia. He was described as a brash young man who wouldn't believe his elders. So his pathologist, who was the older person here, Robin Warren, Barry used to take biopsies from the stomach in all these ulcer patients. And the Robin Warren found these Helicobacter pylori in them. And so when Barry Marshall said bacteria are the cause of ulcers, nobody believed him. In fact, for 10 years, until many scientists in the US had replicated his work and shown that it would help treat peptic ulcers, nobody believed that bacteria caused ulcers. And Shinya Yamanaka is another person who, those of you in stem cell research will have heard of him. He was a Japanese physician, trained initially as an orthopedic surgeon, decided to give that up and took to stem cell research. Now, he used a typically surgical approach. He used a very unconventional approach. Until then, people used to think that you could not convert an adult cell back to a progenitor cell, to a pluripotent stem cell. What he did was to take 26 transcription factors and push them into these adult cells. And lo and behold, the adult cell became a pluripotent stem cell. And so he originated induced pluripotent stem cells. He narrowed it down eventually to 4 factors. But, and again, he got the Nobel Prize for this. So these are just examples that I give you. Let's just briefly look at the qualities of a physician scientist. Now, when you think of a physician versus a scientist, generally you think that a physician is a man of action or a person of action. A scientist is a person of thought. The physician, if he gets to know of some knowledge, he tries to see how can I apply it for my patients. On the other hand, the scientist uses that knowledge for discovery. With a physician, the decision-making is rapid. For a scientist, the decisions are generally slow. Very interestingly, and this is the opinion of other people that I've cited here. So physicians almost always adhere to accepted standards of practice, whereas scientists almost never adhere to accepted standards of practice. Physicians respect authority, scientists question authority. And when they make a mistake, the physician says, oh, where could I have gone wrong? You know, how should I have done it right? The scientist says, I did something wrong. This is what it resulted in. And then that's the basis for a breakthrough. In fact, that's the basis for discovery of penicillin, for the discovery of Campylobacter jejuni, and so Helicobacter pylori, the way it grew, and so on. Why do we need physician scientists? So we all know that the buzzword today is translational science or translational medicine. Now think of translation. You want to translate something from Odia to English. You require a person who is fluent in both the languages. Similarly, translational medicine requires a person who's fluent in both clinical medicine and in laboratory science. That is, that they should have active laboratory research programs, and they should understand the needs and the practicalities of clinical medicine. So this is a question for administrators. If we want to foster this class of people, physician scientists, to what extent can we do it? So what extent is a part of the makeup of the person, and to what extent does nurture create this? So I believe, and this is my own interpretation of it, I think what is natural, what comes naturally to the person is that the person should be curious. They should be open-minded. All scientists should be open-minded. You should never think that I'll only go this way. It could go this way or that way. And the open-mindedness is what creates results. Motivation, I think, is inbuilt. And the ability to focus is very important. So when I was a kid, my grandfather used to tell me that you need to focus. And he didn't call it focus. He called it tapas or tapasya. And that's a term that we are all familiar with. What tapasya actually means is that you discipline yourself to obtain an objective. And that's very important. What is nurture? So nurture is what the environment can create for you. One is that we can create awareness in people that there is a possibility like this. Mentoring is very important, extremely important. Access to critical thinking is important. So you cannot live in a vacuum. You cannot live in an isolated place and think all. I mean, I say this when I say I cannot, obviously there's nothing that you cannot. The majority of us, we need access to critical thinking. We need access to people who think along similar lines, who think differently, on whom you can bounce your ideas. And lastly, and most importantly, we require funding. So funding is something that the government has to think about, science agencies have to think about. So let's just look at the importance of environment and nurture. And basically, I'll just very quickly take you through how I became a physician scientist. I always wanted, even from school, I had an early desire to become a doctor. And I thought I'll go around curing people. Somehow that, and I'm saying this with all humility, that somehow that's something that I wanted to do. But as I went through high school, I read books which were outside of my curriculum. And I became fascinated with the physiology of the human body. So I went to college, I joined CMC, Vellore, and my focus was entirely on learning medicine. So all those years, 5.5 years, I spent just focusing on medicine and becoming good at it. It's only when I actually went on to do my MD in general medicine and did my thesis that I had my first introduction to research. That's when I understood that generating knowledge, whatever is cited in the textbooks, is something that is within the reach of all of us. So each of us should be able to generate knowledge which is used by others. It will be cited in textbooks. And in fact, my work as in the MD was based on this gentleman who was in Vellore at that year. He was my teacher, Michael Hellier, an Englishman. And so he studied intestinal absorption with tubes in the intestine. And he compared English people and normal Indian people. He also compared patients with tropical sprue, which is a diarrheal disease where people were losing lots of fluid from the intestine. And he said in the tropical sprue, it doesn't look like there's an excessive loss of fluid from the small bowel. So he set up a question for me, which is to say, where could they be losing from? So could it be the large intestine? In fact, that's what my MD thesis was based on. I looked at colonic absorption in tropical sprue. And when I finished, this paper was published in Gut, which is the Journal of the British Society of Gastroenterology. At that time, Gut was number 2 in the world in terms of gastroenterology journals. The first was Gastroenterology, which was the Journal of the American Gastroenterology Association. That next came Gut in terms of impact factor. So it was a great boost to me. So I said, hey, we can all do this. My mentor was Professor Martin, who was a gastroenterologist, he was the head of the Wellcome Research Unit in CMC and later the director of CMC. Dr. Martin was a man of great intellect. He was a great team leader. He built a team, which I'll show you in a minute. But more importantly, on those days, every day we used to go on ward rounds. I and 3 or 4 of us who were all of the same age working with Dr. Martin. And those days we had a lot of time because we had few patients. It's not like the pressure we have today when you have to run through your patients. There's so many of them that you find it difficult to cope with them. So against each bed, we would stop. We would discuss what's wrong with the patient. We would discuss the results. We would discuss what could we do. And we would discuss lacunae in knowledge. And these discussions were exciting because when you discuss lacunae in knowledge, you also thought about ways of generating that knowledge. So this kind of training on the ward, on rounds, was very important in making not just me, but a couple of my other colleagues, they're physician scientists as well. So this was a photograph of the Wellcome Research Unit, maybe about 4 or 5 years before I joined it, but it gives you a kind of idea of the unit. So it was housed in this building, which is called the Williams Research Building. There's 4 floors or 5 floors. And the entire thing was the Department of Gastroenterology. We had a pathology and electron microscopy below. We had the clinical wing. We had a microbiology and virology wing. We had a biochemistry wing. We had a cell biology wing. And above that, we had an animal house. So this is what it looked like, and these were the number of people that were working in it. So we had a great environment where we had people with very, very different kinds of expertise, that we could look at a disease from many different angles, that we could bring it all together. And moreover, we had the facilities to do that. We had reasonably, at that time, state-of-the-art equipment. So these were some of the people that worked in the Wellcome unit. Professor Radhakrishnan, who was later director of the National Institute of Nutrition, he looked at the biochemistry of intestinal absorption. Professor Prema Bhatt, who looked at the human gut in South India. Peter Hill, who went back to the UK and looked at fat malabsorption. Michael Hellier, that I talked about. Ian Ross looked at immunology in South India. So all these people made discoveries which are cited to this day. We had Michael Farthing, shown here on the top panel on the right, who was a very, very, very productive person, looked at immunology. Giardia, he spent a year with us. Michael Marsh, who classified the pathology of celiac disease. Jeff Lee, who looked at the immunology of the small bowel, and John Cummings, who looked at nutrition. And so the passage of this galaxy of individuals through our midst really stimulated us, in the sense that we would be able to talk. We would have tea in the morning, or tea or coffee or whatever we did, or we'd have a break. We'd all sit around a table and we'd discuss. And that really made a huge difference. So as time went by and I became sufficiently senior, I was head of this thing, we realized that it's very important to create awareness in young minds. And along with 3 colleagues, that is Dr. Alok Srivastav, who's a hematologist in CMC, Dr. Ajit Varki, who was a year senior to me and who's extremely well-known scientist in the US, and George Chandy, who discovered potassium channels and lymphocytes, and he's also in the US. The 4 of us together, we decided that we'd create a series of symposia in CMC once a year, where we would bring a Nobel laureate to come and talk to the medical students. The idea was that all the medical students would be given those 3 days off. They would mark attendance in the auditorium for the winter symposium. And not only the Nobel laureate, but all of our CMC graduates who had gone abroad and had done well in research, and of which there are a large number of people. They would talk about their subjects, and they would sensitize these young medical graduates to the fact that you can do research as a career. And so this is the first winter symposium that we held in 2003 in the Scudder Auditorium. And the speaker, the main speaker was Peter Hill, who years before, Tim Hunt, who 2 years before had won the Nobel Prize for his discoveries in the cell cycle, of cell cycle regulation. Basically, he discovered cyclin. And you see the throng of students around him. They were all extremely enthusiastic when this happened. So in the subsequent 9 years that I was still in CMC, I organized 3 more of these winter symposia. We used to organize these every year, but I personally organized 3 of them. And we did find, as we did a study, that a certain number, maybe, I mean, it's not a huge percentage, maybe 2 or 3 in each batch decided that they would take up research as a career. Now, having sensitized them, the next thing to do is that you need to formalize training and career. If you remember in one of my initial slides, I talked about William Osler formalizing physician training from the informal training to the residency system. So similarly, we need to formalize training for physician scientists. In the US in 1909, they set up an association for the advancement of clinical research. The first president was Samuel Meltzer, and he said clinical science will not thrive through chance investigations from friendly neighbors. That is, you cannot just take somebody who's a biochemist and somebody who's a physician and expect that they will make clinical science for it. I mean, it may happen randomly. If it happens, that's great. But you cannot expect it to happen all the time. So he also said that physician researchers must have a training fitting them to carry out investigations in conformity with the requirements expected in all tests. So we need formal training programs. So earlier generation, that's me, we taught, or we had informal apprenticeships. I learned from so many people. I learned when I was doing my MD and I was doing lab work, doing lab biochemistry. The person who was doing PhD there, the way he taught me, the way he rigorously did things is with me till today. So that was self-taught. What we require is formal training and funding for budding physician scientists. In the US, these are available through MD, PhD programs. In the UK, they are available through Wellcome Trust fellowships. In India, the India Alliance offers fellowships. And I think that I played a reasonable part in this because I used to speak with Professor Vijayaraghavan, who is currently the principal scientific advisor to the government of India. And we used to say that we need to encourage physician scientists in India. And eventually they created a separate set of fellowships which are applicable only to clinician scientists. We also have short-term courses offered by medical colleges, universities, by government and non-governmental organizations, but these are very voluntary. So having gone through a formal training, we also need to have a career path for them. In the US, this happens very easily because there's MD, PhD programs, they go through research track clinicians. So they are clinicians, say, for 3 months of the year or 6 months of the year. They are researchers for 3 or 6 months of the year, 6 or 9 months of the year. In India, we have ICMR institutes. We have institutes of national importance like AIIMS Bhubaneswar, all the AIIMSs. We have self-run institutions like CMC Vellore and St. John's, where encouraged to an extent. So where are physician scientists headed? In the West, there seems to be a decline in physicians, and this is not unexpected. It's because when you're a clinician and you're also trying to do research, the rewards in clinical medicine are so great. You spend a little more time, that it's so much financial reward that you get there. So you don't get anything for doing research. So it's not unexpected that people will move away from this and become more and more clinicians. The American Society of Clinical Investigation was set up to foster scientists. We don't have an equivalent in India. So one of the early presidents of the ASCI, James Wingarden, in 1979, said that physician scientists are a vanishing species. And this was actually reflected again 20 years later by my senior, Ajit Varki. He was a year senior to me in CMC. And as I said, he's a scientist in San Diego. And he was at that time president of the American Society of Clinical Investigation. And he echoed what Wingarden had said in a kind of satire. So what options do physician scientists have for research? I mean, obviously, they could do basic science research. A prime example is Jeffrey Gordon, who in Washington University School of Medicine, who is probably the father of microbiome research currently, on molecular microbiome research. Or you can do applied research. You could innovate surgical procedures. You can innovate medical. You could be clinical trialists. You could do operations research. You could do descriptive research. All of these has a place in generating knowledge, in improving our delivery of healthcare, in improving the health of humankind. So I'm almost here, so I'll basically have a few closing thoughts, which is that what we need to do if we are administrators or looking to foster this group, that we should provide good grounding, both in clinical medicine and in research. We should identify and encourage self-motivated individuals. You should encourage entrepreneurship. We should have a culture of good mentorship. Unfortunately, this is something which is very often lacking in India, but it's something that we should create. We should establish career paths for physician scientists in India, and we should prioritize funding for physician scientist proposals. So with that, I'll stop and acknowledge the people who've helped me enjoy life both in the lab and outside. Thank you.
Just your last remark of closing thought, that was on funding. Many physicians feel that fund restriction is a very hurdle for them. Can you give your certain suggestions when there is a fund limitation, how the physicians can generate good evidences and can work our research?
Right. So when there is fund restriction, obviously it's going to be extremely difficult. So the government of India, as you know, has many funding bodies. And due not only to what I have talked about with Dr. Vijay Raghavan, there are others also that who've interacted with him, Dr. Rakesh Agarwal, for instance. And so what has come out of that is that that particular funding scheme has funding which is captive for physician scientists. If you have a good idea, if you know how to express it, if you can defend it, they will fund you. Now, there are other funding schemes of the Indian government, of which I've sat on many funding committees, and I continue to sit on funding committees. And at least what I have done and what I've encouraged other people to do, which many people have done, is to say that excellence or funding should not be confined to centers of excellence. If we can get somebody in a small place who has a good idea, he has a sharp mind, it doesn't matter if he has no experience, encourage them. So we've tried to apply that in practice. So the bar is kept lower for people who come from places which have no track record, but there seems to be somebody who's enthusiastic. So there are many other ways to make it in each funding organization. that they can set aside money for this. But your question was, how can we do it if these funds are not available? The answer is, I think you'll have to get funds from the authorities in your institution. Maybe they can get a fund from people. What I have seen is, when I've worked abroad, is that many people try to appeal to the general public, and they hold lotteries, so there's so many other activities that they have which generate a little bit of money. The other thing that you can do is to conduct meetings. When you conduct a meeting, a professional meeting, you get money in from various sponsors. And you invariably end up with a significant amount of money left over from that, which you can use to kickstart your research.
Yeah. Very good idea, sir. I request Madam to take suggestions, sir.
Thank you, Professor Radhakrishnan. I really love your talk. A lot of takeaway messages for us and for many of the people who are listening. Because in order to encourage, motivate, it is not just us as administrators. Definitely, we need to do more. Of course, in AIIMS Bhubaneswar, like in many of the other institutions, we give some seed money or an intramural grant of 5 lakhs now, which sort of encourages them to start small projects which they can perhaps publish and use those results to write up, medium level grants. But many times I have seen that that's not actually happening. That loop doesn't get closed in many of the cases. So we give the grants, but we are not seeing that happen. Perhaps it will take some time. But also, I think we need, the thing is, in new institutions like ours, we don't have a kind of a culture of, motivating, nurturing. These things need to be started. And we also need to start, getting people to listen to big minds, speak and, connect with. So thank you very much, sir. If anyone would like to ask another question or two, I think Professor Ramakrishna would be happy to answer. Just 1 or 2 questions.
Sir, I'm Dr. Rohit, Senior Resident Urology.
Please go ahead.
Yes, sir. Yes. Sir, I have a small doubt, sir. If at all we are working with multiple institutions, may, for example, an institution.
I'm sorry, you're muted.
Yeah, unmute yourself. Yeah.
Sorry. Yes, sir. Sorry, sir. I'm Dr. Rohit, sir, from SR Urology. Sir, if at all we are working on some, say, a project in which both an engineer or a doctor or something of this sort, 2 different institutes are, going ahead and doing a project or something like that. And if at all we need some granting or something in the form of, say, for example, big grant, biotechnology ignition grant or something of that sort. Do we have any funding agencies that can sanction grants? Which are already established, which will happen every 6 monthly or yearly, which will give us. And if it all is occurring in between 2 institutions, what will be the implications and what are the steps ahead of it, sir?
Happy to answer that. I think any funding agency will look positively at an interaction between engineers and doctors in terms of creating something. In terms of funding agencies within India which are rapidly responsive, I would suggest applying to the Department of Biotechnology. They provide the most rapid response, they provide good funds, and if you have a sensible idea and if you can defend it, but that is what is most important. When you go with that idea and you tell them, you should be able to defend it with passion. And if you can do that, it's almost certain to be funded. And if you take your engineering colleague along and both of you say this is what we do, they might realize that you may be naive in certain areas, but they will try to help you with that. And I have absolutely no doubt about that.
Sir, one more small doubt, sir. When we are working as a faculty in an institute or something like that, we are not supposed to practice outside or have another second financial source. The main intention of this medical devices or maybe inventions from the medical side is to go ahead with entrepreneurship such that it will hit the market and it will be helpful to the people. So will we have permission to head a company and be a faculty in an institute at the same time?
Oh, okay. So there are many models. There are US models for that very clearly. I mean, if you're working full time for an institution and if you generate intellectual property, it generally becomes the property of the institution. And you will get acknowledgement as the scientist. Beyond that, it would depend on whether financially you will get motivation will depend on the rules of the institute where you're working.
I think private institutions won't have a problem, but government institutions, you cannot hold another job as a government employee. So there are some models, of course, IITs, they have a different model, but as of now, when you are working in a government institution like AIMS, you cannot do that. So thank you very much, sir. From all of us for this talk, and we will be proceeding.
Thank you very much.
Thank you, sir. Thank you so much.